Good morning. Today I would like to cover cyclic codes. Cyclic codes are the subclass of linear block codes. They have the property that a cyclic shift of one code word produces another code word. Here we can consider n-bit code vector. X is the code vector. X is equals to x of n minus 1, x of n minus 2 up to x of 1 and x of 0. Here we can consider it as equation number 1. X of n minus 1, x of n minus 2, x1 and x0. This represents individual bits of code vector x. These are the individual bits of code vector x. X is the code vector. Now, by shifting above code word cyclically, we will get another code vector x dash. Now, x dash can be getting by cyclic shift of this code vector x. Here x dash is equals to x n minus 2, x n minus 3, x1, x0, x n minus 1. Now every bit should be shifted to left. Here these bits are shifted to left. This x of n minus 2 takes the position of x of n minus 1 and x of n minus 1 will shifted here. Now initially x of n minus 1 was the MSB bit, but after the cyclic shift it is at the LSB position. Now if we shift this code vector by one more left shift or cyclic shift, then we'll get another code vector, that is x double dash. X double dash equals to xn minus 3, xn minus 4, x1, x0, xn minus 1, xn minus 2. Here we can consider it as equation number 3. Now the definition of cyclic code. A linear code is called cyclic code if every cyclic shift of the code vector produces some other valid code vector. The code vector can be defined with the help of polynomial of degree less than equals to n minus 1. Thus, code vector of equation 1 can be written in terms of polynomial as x of p is equals to x of n minus 1 p to the power n minus 1 plus x of n minus 2 p to the power n minus 2 up to x1 p plus x0. Now where p is the arbitrary variable. Power of p represent the position of the code word bits. This power of p represent the position of the code word bits. Now multiplying equation number 4 by p. So if we multiply x of p by p, then we'll get p x of p on left hand side is equals to x of n minus 1. P raised to power n minus 1 into p is p raised to power n minus 1 plus power of p is 1. Therefore 1 will get cancelled and it is x of n minus 1 p to the power n. Like this, x of n minus 2 p to the power n minus 1. The power will decrease by 1 plus x1 p to the power 2 or p square plus x naught p. Give it as equation number 5. Now let us form polynomial of code vector of equation 2. So what is the polynomial of code vector of equation number 2? X dash p is equals to x of n minus 2 p to the power n minus 1 plus x of n minus 3 p to the power n minus 2 plus x1 p square plus x naught p plus x n minus 1. Consider it as equation number 6. Now adding equation number 5 and 6 by mod 2 addition rules. Modulo 2 addition we can do here, equation number 5 and 6. So if we add left hand side, then it gives us p x of p mod x dash p is equals to x n minus 1 p to the power n. Now here you can see in equation number 6 there is no term which is having power n. P to the power n, there is no term, so this term is alone here. Plus here we have to add the same power terms, plus x of n minus 2 mod x of n minus 2 p to the power n minus 1 plus x1 mod x1, this x1 mod with this x1 bracket complete p square plus x naught mod with this x naught bracket complete into p plus again this is one term which is getting left, so here plus x of n minus 1. This is equation number 7. Now this equation gives us p x of p mod x dash p is equals to x of n minus 1 p to the power n plus x of n minus 1, because same terms when we are when we do the modulo 2 addition is nothing but the XORing. 0 XOR with 0 is 1, 1 XOR with 1 is 0. Okay, therefore x of n minus 2 mod with the same term x of n minus 2, it gives us 0. Similarly for this 0, and this is also mod 2 addition will be 0. Therefore here at the right hand side we will be getting only two terms. Here we can take x of n minus 1 common, then in bracket p raised to power n plus 1. Then what is x dash p? X dash p is, if we take this term on the right hand side, then x dash p is equals to p x of p mod x of n minus 1 into p raised to power n plus 1. Now this is an iterative equation. This equation is an iterative equation. X dash p code vector generated from x of p. This x dash p code vector is generated from x of p vector. Now x of p can be represented as, here we can represent x of p is equals to m of p into g of p. Now where m of p is the message signal polynomial of degree less than equals to k, and g of p is the generating polynomial of degree q. For n comma k cyclic code, now if we consider n comma k cyclic code, then generating polynomial is given as, for n comma k cyclic code, generating polynomial is given as g of p is equals to p to the power q plus g q minus 1 p to the power q minus 1 plus g1 p plus 1, where q is n minus k. It is number of parity bits. Q is the number of parity bits. Now message polynomial m of p is defined as, how we defined a message polynomial m of p? It is m of p is equals to m k minus 1 p to the power k minus 1 plus m k minus 2 p to the power k minus 2 plus m1p plus m naught. Similarly, other code vectors can be defined as x1p is equals to m1p gp, x2p is equals to m2p gp, x3p is equals to m3p gp. In this fashion we can represent cyclic codes, and these code vectors are represented in terms of message and message polynomial and the generating polynomial.